Alright, here's some net ionic equation and just writing equation questions in question 4. So the first thing that you want to do is look at the phases of matter that are in each one of the substances. If they're solids, of course, you can't write you can't split them up in a net ionic. Solids and pure liquids, of course, never splits. And then if they're aqueous, they probably split, especially if they're the strong acid or a strong electrolyte. A strong electrolyte would be a salt, something that's got a metal and a nonmetal, and then it's on the list right here of the mainly water solubles. Then they'll split. So the ones that you know to split up into ions, remember, are the strong acids, the strong bases, and then the soluble ionic salts. And the salts, remember, are the ones that you find on the chart right here. And just to remind you of a few of them, nitrates, acetates, and chlorates are all soluble. Chlorides, bromides, and iodides are all soluble except for silver, mercury, and lead. And then you can see the alkali metal cations, which are these guys, are all soluble, and they'll split up all the time too. So being good at recognizing what kind those are allows you to know if they split up. So when we write the net ionic for this, we'd write it as CaOH2, solid, so don't split it, plus 2H plus 2Br minus. Split that one and don't forget to distribute the 2. And then over here, this is aqueous and it's a soluble ionic salt, so Ca plus 2, and then 2 Br minuses. Don't forget to put the 2 in front of the Br. And then we have 2H2O, pure liquid, so keep it together. When you write the net ionic then, the Br minuses would cancel with one another. The underlined species right here would give you the net ionic equation. Letter B, sulfuric acid is neutralized by aqueous potassium hydroxide, and they just want the full molecular equation, so we're going to get some water and we're going to get some K2SO4. So this is an acid, this is a base, it's an acid-base reaction, so we get a water and a salt, and the salt we get is potassium, which potassium of course is +1. If you look on the periodic table, it's in group 1, and then sulfate's a -2 polyatomic ion, so you have to have 2 of these to balance that out. Balancing the reaction, then you need a 2 here, and I believe a 2 right here. Letter C, nickel metal is oxidized to its +2 state, so it's going to be +2 over here, in a reaction with hydrobromic acid. So hydrobromic acid is HBr, and it says write a full molecular equation. So nickel is going to replace the H right here, become +2, go with the Br, which of course is -1, so you'll get NiBr2, and then you'll get hydrogen by itself. Careful, don't get tricked. Hydrogen by itself is diatomic, so it's got to be 2. 2 right there to balance it. Last one, ethane gas. Ethane C2H6, prefix eth means 2, and then ane means it follows the C to the X, H to the 2X plus 2 format. If you forget the prefixes, remember they're located right here. Organic prefixes. A combustion reaction means it's going to react with oxygen, and then there's always the same products for hydrocarbon combustion. You always get water, and you get carbon dioxide. 2 carbons, 2 carbons, 6 hydrogens, so you're going to need a 3 here. So that gives you 6 hydrogens, but now your oxygens are going to be messed up because we're at 4 plus 3 or 7, so to get 7 you'd need 3.5 right here. So this would get it to you with using halves, but if they say whole number coefficients, take the whole thing, multiply it by 2, and then you get 2 C2H6 plus 7 O2s. 2 times 3 is 6, 2 times 2 is 4, and then you have the balanced molecular equation with whole number coefficients. That's question 4.